solving absolute value equations. Absolute value equations are equations where your variable x is inside absolute value bars. We will be solving linear absolute value equations. In order to solve an absolute value equation, we want to get it set up in this form, where we have the absolute value by itself equal to some number k. In order to solve this, we're going to rewrite it as two separate equations, as the equation ax plus b equals k, and as the equation ax plus b equals the opposite of k. Because absolute value is defined as the distance a number is from 0. So we don't know whether that distance is going to be to the left of 0, which would make it a negative k, or to the right of 0, which would make it a positive k. So let's solve some equations. The first one is the absolute value of 2x minus 5 equals 4. So my absolute value is by itself. So I just rewrite this as two separate equations. I'm going to use the 2x minus 5. I don't change anything at all about what's inside the absolute value bars. I just set it equal to 4, and I set it equal to a negative 4. And then I solve each of these equations. So here I'll have to add 5 to both sides, which is going to give me 2x equals 9, and then divide by 2. So x would equal 9 over 2. That's one of my solutions. Then I solve the other equation. I add 5 here. So this will give me 2x equals 1. So when I divide by 2, I get x equals 1/2. So these are the two values that if I plug it back in for x, this equation will be true. Now I want to look at this problem graphically. So let's come over here and look at the calculator before I do the next example. And I want to look at the graph of this. Remember that we can solve equations graphically by putting the left side of the equation in y1 and the right side of the equation in y2. So we're going to do that. Go to your y equals screen, and to get to the absolute value function, you go to the math key, then you arrow over to the num column, and it's the first option there. ABS, then inside the parentheses you put whatever is inside the absolute value bars. So for this problem, it would be 2x minus 5. Then I put the right side of the equation in y2. So y2 would equal 4. Now, I want to look at a standard window. So I do zoom 6, and I see the first graph. The V-shaped graph is the absolute value graph. And then here is the line y equals 4. So I see two places where these intersect. Remember, graphically, your solution is where these intersect. So this one would correspond with the x equal 1/2, and this intersection would correspond with the x equal 9/2. Remember how you can find that graphically. You do second trace and go down to the fifth option, which is intersect. And you just use your side arrows to move your cursor close to the intersection. Once you get it close to the intersection, do enter, enter, enter. As long as you stay close, that's all that matters. So there's the x equal 0.5, which is this solution. Now I'll need to do the same thing to find the other intersection. Second trace and choose the fifth option. Once I get it close to that intersection, I'm just going to do enter, enter, enter. and I get the x equal 4.5, which is the 9/2. So I can also solve these graphically. Okay, well here's another problem, another equation. I have the absolute value of negative 3x equals 39. I want to do the same thing with this. I want to take whatever's inside the absolute value bars, which in this case is a negative 3x. I want to set it equal to 39, and I want to set it equal to negative 39. So then when I solve each of these, I'll divide by negative 3, and that's going to give me x equals negative 13 for my first solution. When I solve the second equation, I'll also divide by negative 3, but that's going to give me negative 39 divided by negative 3 is, in this case, a positive 13. So my answers here are a positive 13 and a negative 13. Let's just look at a couple more here. In this equation, absolute value of x plus 5 minus 8 equals a negative 8. The first thing I have to do is get the absolute value part by itself. So I've got to add 8 to both sides of my equation. So this is going to give me the absolute value of x plus 5 equals negative 8 plus 8 is 0. It's okay to have a 0 there. It just means that when we take this out of the absolute value bars, I'm not going to have two equations. I can really only make one equation out of that, because there's not a positive 0 and a negative 0. They're the same thing. So when I solve this, I'll subtract 5 from both sides to get x equal negative 5. So here I would only have one solution. If I look at this equation, I have the absolute value of something equals negative 5. It doesn't matter what is inside this absolute value bars. Anytime you take the absolute value of something, your result is going to be non-negative. It is never going to be negative. So anytime you have the absolute value of something equal to a negative number, this is going to have no solutions. No solutions. If we were to look at this graph, here I want the absolute value of 4x minus 6 equal to a negative 5. What we see here is we see the same v, but then our line is way down here. So there are going to be no points where my absolute value graph intersects the line y equals negative 5. So there are no solutions.